Okay, in example 5 here, it wants us to simplify this fraction. So we got secant of x plus 1 times secant of x minus 1 in the numerator over sine squared of x. Well, the first thing I see is in the numerator here, we can get rid of these two fractions if we go ahead, we can get rid of those parentheses if we go ahead and multiply them. So I'm going to go ahead and do FOIL and multiply them through. Secant times secant is secant squared. Secant times negative 1 is negative secant. 1 times secant is positive secant. And then 1 times negative 1 is a negative 1. Now, I can still simplify here in the numerator. I've got like terms right here. So I'm going to keep my secant squared of x. And what's negative secant of x plus secant of x? Well, negative 1 plus 1 is 0, so those cancel. And I have my minus 1 over sine squared of x. Now, we're just simplifying. So anytime I see a trig function squared and a 1 together, like we have in the numerator here, I automatically think, is there a Pythagorean identity that I could possibly use? Alright, so let's look at our Pythagorean identities, and let's look for the one that has a secant squared in it. So when we look back, I see that tangent, I'm going to write it over here, so I see that tangent squared of theta plus 1 equals secant squared of theta. Now, in order to make this over here on the right look like what I have circled on the left, I need secant squared and 1 to be on the same side. So what if I just move this 1 over? So when I do that, I've got tangent squared of theta is equal to secant squared of theta minus 1. Now, is this right here what I have circled up there in my problem? It is, and since it is, I can use that Pythagorean identity and change that numerator. Instead of putting secant squared of x minus 1, I know with the Pythagorean identity that that is equal to tangent squared of x, and I'm going to keep that over sine squared of x. Now, guys, remember we talked about before, there's different routes to do here, okay? So I'm just going to use what we've talked about in this lesson, though. So I see that I have two trig functions over each other, and it's not a reciprocal identity or the quotient identities. So what I'm going to do is I'm going to decompose these. So this is the same thing as saying tangent squared of x times 1 over sine squared of x. Well, I recognize that tangent squared of x is a reciprocal, is a quotient identity. And so we know that tangent squared of x, I'm going to just write it below it here, is the same as sine squared of x over cosine squared of x. And then it's still being multiplied times 1 over sine squared of x. So now when we do this, algebraically, we see we have sine squared on top and bottom, so it will cancel, which leaves me with 1 over cosine squared of x. And 1 over cosine squared of x is a reciprocal identity. The reciprocal of cosine is secant, so this is going to give us secant squared of x. And we can't simplify any further than one term itself, so there is our solution.